Good morning. ಏನ್ ಮಾಡಿದ್ವಿ ನೆನ್ನೆ ಮಾಡಿದ್ದು ಒಂದ್ ಸ್ವಲ್ಪ 5 minutes ರಿವೈಸ್ ಮಾಡೋಣ. After that we can start with today class. Atmosphere. In atmosphere, what all we discussed yesterday? First one, clouds. First we have discussed about composition of atmosphere. What are the major components of atmosphere? Sorry? After studying composition, what we discussed? Structure. In structure, how many layers do we have? 5. First layer, troposphere. Tell me 2 points related to troposphere. Any 2 points? Lowest layer of atmosphere. Then yeah, up to 18 kilometers near the equator, 8 kilometers near poles. Then weather related activity. Good. After troposphere, we have any 2 points related to stress. And when the height increases, temperature increases in stratosphere. You missed something. When height increases, when altitude increases in troposphere, temperature in troposphere, what will happen? Temperature decreases. Temperature in troposphere with increase in altitude, temperature decreases. This phenomenon is known as normal lapse rate. After troposphere, stratosphere, which layer will we have? Tell me something about mesosphere. Up to 80 kilometers. Good. With increase in altitude, what happens to the temperature? Good.
Up to 100 Celsius.
Minus 100. Make it minus 100 degrees. 80 kilometers. At 80 kilometers, we will get minus 100 degrees Celsius. After mesosphere, which layer we have? Thermosphere. What happens in thermosphere?
Charged particles
radio wave signaling. Okay. After that, we have exosphere, where we see enormous increase in temperature will increase in height. Okay. After discussing structure of atmosphere, what we done? Yeah. Insulation and heat pressure. Insulation and heat budget. Heat budget says the amount of incoming solar radiation is equal to the amount outgoing radiation, outgoing terrestrial radiation. Okay. After that, what we discussed? Clouds, types of clouds. How many different types of clouds we studied? How we classify the clouds based on their height? Appearance. Based on height, how many clouds we have? High clouds, three types: high clouds, mid clouds, and low clouds. Along with them, one more extra vertically extended clouds. Can you name 3 high clouds? Types of high clouds. At least have you observed when you move out of the class? Have you observed the sky? No. No. Cirrus. Good. Middle clouds. Middle clouds. Can you use? Sorry? Middle clouds. Alto. Loss. Hydrostratus and cumulus. Low clouds. Okay. Vertically extended clouds. Nimbus. Okay. After dealing with clouds, what we discussed? Precipitation, forms of precipitation. We are not dealing in deep with precipitation as of now. Okay. After that, types of rainfall. We have three major types of rainfall which are there. Good. After rainfall,
Atmospheric winds.
winds. In winds, what is wind? Horizontal movement of air. After that, winds we have discussed about major pressure belts of the world. Pressure belts of the world. What are the major pressure belts of the world? Polar ice. These are the four major pressure belts. These pressure belts are present in both the hemisphere, both in northern hemisphere and also in southern hemisphere. Let us continue from that pressure belt. We have permanent planetary winds. Today's topic, first topic is permanent planetary winds. You just first try to understand what are permanent planetary winds. These are, as the name says, these are more or less permanent in the region. These are more or less permanent because of the distribution of sunlight. Because of distribution of sunlight, as the sun shines 12 hours in a day near the equator. Is that true? Near equator, every day we will see 12 hours of sunshine. Because of this sunlight variation, the temperature in the equatorial region remains almost the same throughout the year. Due to that reason, these winds will form and these winds will remain permanent. Throughout the year, we will see such kinds of winds. Okay, first tell me, yesterday what we discussed, what is this one? Equatorial low pressure belt. After equatorial low, we have subtropical high. Let me name in short form subtropical high. In both the hemisphere, we have this. Then we have subtropical low. Lastly, we have polar high pressure belt. I will give an example now. You just think what is the phenomena, okay? Suppose in this container, you have a camphor, what we call karpura, camphor. Oh, okay, camphor is here, which is, for example, it is 100-gram camphor, okay? You will go outside, you will come to class. After the class, when you visit your home, due to its open lid, okay, the lid is not closed in this camphor. When you go home, the content of camphor reduced to 75 grams. Why it is so? What happened to the camphor? It evaporates. It evaporates from higher concentration to lower concentration. Rather than saying evaporation, it is the process of diffusion. Process of diffusion happens not only for camphor, be it your perfumes, be it your air sprayers, anything, they will diffuse from higher concentration to lower concentration. Okay. The similar phenomena happens in the Earth's atmosphere also. The air will travel from high pressure region to low pressure region. Anywhere this phenomenon is common, anywhere where is the pressure is high, it will move from high pressure areas to low pressure areas. Low pressure areas are like empty. Low pressure areas are like, they have less amount of air molecules. They are like empty classes. Okay. Low pressure areas are like less dense, whereas high pressure area have more amount of atmospheric air molecules. In such a situation, the air will travel from which area to which area? From high pressure area to lower pressure area. Okay. After knowing this, you only tell now, from here, we have high pressure belt here, we have low pressure belt here. In the sense, where will the wind travel from? Wind travels from? Good. They will travel from high pressure to low pressure area. The wind travels from subtropical high to equatorial low pressure belt. Okay. In the same phenomena happens in the southern hemisphere. The wind travels from subtropical high to equatorial. This pressure belt, this is known as planetary wind. The red one, which I marked in red color, these are known as planetary winds. The flow is almost permanent throughout the year, hence they are known as permanent planetary winds. Okay, they will flow from subtropical high region to equatorial low. After saying that, do you have any doubt? I have written only in one direction. Why not in this direction? Do you have that doubt? Winds move horizontally. Okay, what I'm asking is, while drawing the winds from subtropical high to equatorial low, I just marked from only one direction. Why can't wind travel in this direction in the upper hemisphere? Why can't they travel this direction in the southern hemisphere? Don't you have this doubt? Why not? Why not wind can travel? Only they are traveling towards the west direction, southwestern direction. Why not in the southeastern direction? Will it pop in our mind? Why I have directed them only in single direction? At least yes or no? ಅನ್ಸುತ್ತಾ ಅನ್ಸುತ್ತೆ ತಾನೆ ಯಾಕೆ ಒಂದೇ ಕಡೆ ಬರ್ದಿದ್ದಾರೆ ಯಾಕೆ ಎರಡು ಕಡೆ ಬರ್ದಿಲ್ಲ ಅಂತ. We have a phenomena called as Coriolis force. Coriolis force. What does Coriolis force means? This is the force generated due to rotation of the earth. Think about a ball. If it is rotating, it will generate a force. Think about your bugri, a spinning toy. If it is spinning, it will generate some amount of force, right? Around the bugri sutta ಒಂದು ತರ force ಬರ್ತಾ ಇರುತ್ತೆ. Similarly, around the earth we have one force due to rotation of the earth, that is known as Coriolis force. Okay, this Coriolis force helps the winds to flow in particular direction in northern hemisphere and particular direction in the southern hemisphere. Please you just write note, Coriolis force. Coriolis force is a force generated due to rotation of earth. Force generated due to rotation of earth. Here, this is the main reason for single directional flow of winds, permanent planetary winds. Okay, now listen. You have subtropical low, and subtropical high. Now, from where to where the wind will move? Subtropical low to high. High to low. Exactly right. They will travel from subtropical high to subtropical low. And the direction will remain only in single direction because of Coriolis force, rotational force of the earth. Okay. Okay. Then last one planetary wind is from polar high to subtropical low. Now let us try to name these winds. There are three major types of permanent planet wind. Let us name them. Okay. First one, the wind which is moving from subtropical high to equatorial low, these are called as trade winds. What is first type of wind known as? Trade winds. They are another name known as easterlies. Easterlies. This first one, I will mark it as 1 and 1 here. These are called trade winds. Why they are called easterlies? Because imagine this is your direction, north, south, east, and west. Okay. The direction from which wind is traveling, the direction from where wind originates is the name given to its wind. Okay. Here, the wind, if you put this compass here, the wind is starting from eastern direction to flowing towards the southwestern direction. So we have the name easterly. Okay. Second major type is known as westerly because it is starting from western side. Second major wind is westerly because it is starting from westward direction, hence the name westerly. Last type of wind is known as polar easterlies. Last third major type is polar easterlies. Are these three clear? First one is known as trade winds. Second one is known as westerlies. Third one is known as polar easterlies. You should not mug up the directions. You should arrive at the direction as I explained you. Okay. Don't just mug up. Just understand the things and write. Okay. After saying so, we have one concept known as doldrums. As I said earlier, this equatorial low pressure belt is also called doldrum. Another name is there for that. I think red is not visible from far, right? It is visible. Are you not feeling well? What happened? Nothing. Are you okay? One is doldrum. This equatorial low is also called as doldrum. The other name is intertropical convergence zone. In short, we will call it as ITCZ. Okay. Is this clear? Why it is called doldrum or ITCZ is a question now. Think. Sorry? It's here. Then the winds from both subtropical ice are moving towards the equatorial region and they are rising up. For example, when winds coming, so this is subtropical high, this is subtropical high, from both the direction the winds are blowing. Equator, they will rise up to the tropopause. Up to tropopause, they will rise upwards, creating a hollow space at equatorial low. Hollow is nothing but they are very low pressure areas, very much low pressure areas where the sailing, the boating is difficult. Okay. The rising air is more rather than horizontal. Thus the name doldrums or intertropical convergence zone because intertropical, between tropics, intertropical convergence. Here what the phenomenon is happening? Convergence of two types of winds, intertropical convergence zone. Clear with this concept? Okay. Then we have westerlies. Westerlies are nothing but these are traveling from west towards east from subtropical high to subtropical low pressure belt. These are permanent in nature. Apart from that, at 30° north, we have some phenomena. Here also, the wind originates. Sorry, the wind originates from this 30° north latitude and 30° south latitude, originating from there, and they will move apart. Either they will move in the upward direction or in the downward direction. Here, what will we get? Same, similar halo-like creation will happen at 30° north also. This 30° north latitude is known as horse latitude. What is this called as? Horse latitude. Why it is named so? Why the name horse latitude? As we explained, intertropical convergence zone, because of convergence of two types of winds, it is known as horse latitude because previously the sailors, the merchants, when they are sailing, they used to sell horses. From European continent, the horses are famous in Europe. If ancient history is covered, you will know about something about horses, horse trading. Arabian horses came to India. They used to sell horses. Okay, while traveling across this 30° north or 30° south latitude, they are facing some difficulty because of no horizontal wind movement at 30° north and 30° south. At such circumstances, what they used to do is the horse present in the ships, whichever horse is like aged horse or some horses which are not feeling well, they used to throw that horse in the ocean air because to reduce the weight of the sailing vehicle. That is why the name came 30° north latitude is known as horse latitude. Okay, clear with that? Okay. That completes your planetary events. Just take the D, planetary events. Try to draw this. Try to draw this diagram. It is easy, right? This one, you just draw this one. Zero degree, 30° north, 60° north, 90° north. Be particular with the directions. That extended. Trade winds, westerlies, polar, easterlies. Finished? Take down this statement. These are called permanent planetary events. These are called permanent planetary events. Because they blow in same direction. They blow in same direction throughout the year. Same direction throughout the year over a large area of Earth. Over a large area of Earth. Over a large area of Earth. Okay. Where you have written 0-degree equator, there you write it is called doldrum. Doldrums. Equator is also called as doldrum or intertropical convergence zone. Intertropical convergence zone. Okay. Then 30-degree north and 30-degree south latitudes called as horse latitudes. 30-degree north, 30-degree south latitudes called as horse latitude. Now just listen me for a few minutes. Correct. These winds which I am drawing here are near to the earth crust. In other words, they are just above the surface of the earth. They are just above surface of the earth. These winds, when they come and contact, these trade winds, when they reach 0-degree, they will rise. They will converge and they will rise. According to ITCZ, as I said, they will converge at 0-degree latitude. They will rise upwards. Okay. They will rise upwards, and the layer between troposphere and stratosphere is known as tropopause. They will reach tropopause and then they will subside. From tropopause, they will come back to the earth again, forming a cell-like structure. They will rise above, they will reach tropopause. From tropopause, they will come back again. This happens mainly due to pressure difference. As I said earlier, here in troposphere, we have high pressure regions at the tropopause level. Then from high pressure to low pressure area, that is equatorial 0-degree, they will come again. Okay. Creating a cell-like structure, that cell is known as Hadley cell. The first cell is known as Hadley cell. First cell is known as Hadley cell. Hadley cell, what will happen? The trade winds will rise and reach tropopause and they will come back again to the 0 degree. Okay. This circulation is called as Hadley cell. Similarly, at second horse latitude also, the upper air circulation happens at the tropopause level, forming a circle called Ferrel cell. Second one is known as FERREL, Ferrel cell. Okay. Third, similarly, at the polar region, the same phenomenon is happening at the tropopause level and it is called as polar cell. Have you got the concept?
All three cells are formed.
Yeah, at the in the sense, like the rising air will reach the tropopause. Okay, when reaching the tropopause, they have high pressure there. Compared to 0 degree, they have high pressure there. Due to high pressure, they have to come for low pressure. No, they will form a side. Okay. At all the three, we have circular movement of air. Write down these three cells. First one is Hadley cell. No heading is necessary. It is actually a planetary wind only. In that, near to the surface, we have trade winds, westerlies and easterlies. Above the layer of troposphere, we have Hadley cell. In the diagram only, you can represent Hadley cell, Ferrel cell, and polar cell. Hadley between equator and 30 degree north or south. Ferrel between 30 degree north or south to 60 degree north or south. These are upper atmospheric circulation. Between 30 to 60 degree north or south. Then we have polar 60 degree north or south to 90 degree north or south. I think the wordings are not necessary as of now because it will kill time. Okay. I have to cover much more topics. Then we have seasonal winds. Okay. Any doubts with planetary winds? Seasonal winds are nothing but these winds change according to seasons. Okay. In seasonal wind, we have one major type of wind known as monsoonal wind. Monsoonal winds occurs due to seasonal reversal of wind direction. Okay, seasonally the direction of wind will reverse. In simple terms, I will explain the monsoonal winds related to India. Okay, in your advanced classes, you will get to know about monsoonal winds, how they occur in the entire world. Or you wanted me to explain the world or India's? World. You wanted me to explain the world's monsoonal winds. Okay. What is this 0 degree latitude is called as? Equator, doldrums, or inonemo? Intertropical convergence zone. Okay. We have 22, 23.5 degree north. Okay. This is India. Okay, think this is India in the world. Both will be covered at a time. Okay. Before going to monsoonal winds, you should know something. What are the line joining the places of equal pressure is called as line joining the places of equal pressure. Such line is called as. Yesterday, I just by passing over, I mentioned these names. The line joining the places of equal pressure is called as no. Albedo is something different which we discussed in heat budget concept. What is the line joining the places of equal pressure? Iso? Isomers. Similarly, the line joining the places having equal temperature. Isomers. Okay. Just know something because I use this word again oftenly. Okay. In 0 degree latitude, how is the temperature? Will it be high or low? Temperature. I'm speaking about temperature. Temperature will be high. The pressure will be low. Oh. Above this, what will be the temperature? Temperature. I'm speaking about temperature. What will be the temperature? How will be the isotherm? Isotherm. Isotherm is nothing but these line joining places. It's comparatively low temperature compared to 0 degree. Okay. This is the basic thing. Now, during summer seasons, because the solstice is not explained to you. Solstice. There are two kinds of solstice. One is summer solstice, another one is winter solstice, which will be dealt during the lesson where we take up rotation and revolution, which is not dealt for you. That's why it is becoming a bit tough for me to explain. Okay. During solstice, for your reference, I will just tell how the solstice will happen. Imagine this is a chapter where we are dealing with revolution of Earth. Okay. Revolution of Earth, where revolution is nothing but Earth is surrounding the sun in certain orbit. Okay. Revolution. During revolution, what happens? The sun vertical rays will fall on equator during sometimes, on tropic of Cancer during sometimes, on tropic of Capricorn during sometimes. When it falls directly on the tropic of Cancer is nothing but half degree north. When it falls directly on tropic of Cancer, we will get northern hemisphere's summer days. Summer days in the northern hemisphere, it is known as summer solstice. The northern hemisphere summer days are known as summer solstice. During another year, another part of the year, that is another month of the year, the sun's vertical rays will fall exactly on tropic of Capricorn. Because Earth is tilted, right? Earth is tilted at how many degrees? 23 and half degree. Because of this tilt, during winter season, the sun's vertical rays will fall directly above tropic of Capricorn. Such phenomenon is known as winter solstice, because northern hemisphere will experience winter colds during such months, because this southern hemisphere will experience summers, whereas northern hemisphere will experience winters. Are this boring? A bit. Go and just fresh up yourselves. You haven't slept night? ಮಲಗಿರ್ಲಿಲ್ವಾ ರಾತ್ರಿ? ಬಂದಾಗಿಂದನೇ ಯಾಕೋ ಹಂಗೆ ಇದ್ದೀರಾ? This is a book provided by them. Show the first page. Good one. The second row. The light there where you are sitting is too dim. ಏನಪ್ಪ ಡ್ರೈವಿಂಗ್ ಎಲ್ಲಿಗೆ ಹೋಗಿದ್ರಿ ಓಕೆ ಓಕೆ ಹಾ ಹಾ ಟಯರ್ಡ್ ಫೇಸ್ ಅಂತೂ ಗೊತ್ತಾಗ್ತಿದೆ ಓಕೆ Okay, now look. This is intertropical convergence. During summer season, sun rays will fall exactly over, sun's vertical rays will fall on 23.5 degree north latitude, which is called as Tropic of Cancer. Sun's vertical rays fall exactly on Tropic of Cancer during summer season. When is the summer month in India? That summer month, we have sun's vertical rays falling exactly this region. During such season, this ITCZ, the line, the pressure belt, the ITCZ line will shift towards northwards. This ITCZ will shift, it will shift towards northward. This is your new ITCZ line. While such shifting, when this ITCZ shift completely towards northern hemisphere, it will carry some amount of moisture. Here we have Indian Ocean, right? Because this is India I have drawn here. Here we have Indian Ocean. It will carry some amount of moisture along with the pressure movement of that pressure belt. This ITCZ, while moving, carry enormous amount of moisture. This moisture will be coming to earth in the form of precipitation. During this season, we will get monsoonal rains. Have you understood how monsoonal rains occurs in India? Because of due to shift in ITCZ from 0 degree to near to the 23.5 degree. During such shift, it will carry enormous amount of moisture along with such moisture will come as monsoonal rains. Okay. As I said, monsoonal winds are nothing but seasonal reversal of winds. Now let us understand what happens during winter season. According to solstice, during winter season, where does sun's vertical rays fall? Sun's vertical rays will fall near Tropic of Capricorn. Sun's vertical rays they will come near Tropic of Capricorn. That is nothing but 23.5 degrees south. During such, this ITCZ should come back, right? The ITCZ is nothing but pressure belt and temperature isotherms. It should come back because the temperature will be high at this area. It will come back or it will retreat. Sorry. It will come back or retreat to its original position. While coming back, this is called as good. It is called as retreating monsoon. It will come back to its original position because of shift in sun's vertical rays. It will come back to its original position is known as retreating monsoon or northeastern monsoon. Direction is northeastward. It will retreat from northeast, hence the name northeast direction, northeastern monsoon. While it is going upwards, the direction is southwest. It will start from southwest, hence it is called southwest monsoon. Is the concept clear? Later on, you can add on your notes during advanced class. Okay, is the concept clear? The first one is monsoonal wind. This happens due to majorly shifted our IT season. When it shifts towards northward, it will bring rain during southwest monsoon. When it comes back to its original position, that is during winter season, it is called retreating monsoon. It is also known as northeastern monsoon. Is the concept clear? Okay, good. Then we have another kind of wind known as sea breeze and land breeze. Sea breeze and land. To understand this concept, give me an example of coastal city. Any coastal city.
Mumbai.
Mumbai is a coastal city. You? Any coastal city. Any beaches you have visited. Goa, good. Goa is near to you, right? Huh? Quite nearer. Okay. Imagine you both were in Goa. You are standing in the beach side, that is in the land side. Here we have. Which sea will come near Goa? Sea. Where is Goa located? Here Goa is located. Which is the sea? Good. It is Arabian Sea. We have sea here. Okay. In Goa, you will have two differences of day and night. Days are hot and nights are cold. Okay. Oh. Imagine now the sun is shining heavily. When sun is shining heavily during daytime, what will happen to the land surface? Will it get heated up or low temperature will be there? It gets heated up. When the temperature is very high in the land, what will be the pressure? Very low pressure. Okay. What happens to the sea during daytime? The sea, compared to land, the sea will get heated up faster or slower? Sea will heat slower. The temperature compared to land will be very low. What happens to the pressure? High pressure. Okay. Our wind will flow from high pressure region to the low pressure region. The wind will flow from high pressure region to the low pressure region. Since it is flowing from sea, it is starting from sea. As will the name of the winds will start from the direction where which it will flow. As it's starting from sea, the name given to this is sea breeze. Is this concept clear? Sea breeze. What is sea breeze? Sea breeze is something, the breeze which is starting from sea and it is traveling towards land area. Okay. This will happen in all your beach sides or coastal cities. Now you are in night. During night, what happens to your land? Will it get land has one phenomenon of getting heating faster and also relieving that heat faster. It will cool down faster. The temperature on the land will be very low and it will experience which pressure? It will experience high pressure. Whereas the sea, the water body will have retained some amount of energy, which it has been heated during daytimes. Hence, comparatively, the temperature will be high, it will experience low pressure. Now, during night time, the wind will flow from land towards sea. Hence, the name land breeze. Because it is starting from land, hence the name land breeze. Is this clear? Okay. This is second major type of wind, local wind. Similar to, in the same fashion, we have one more concept known as mountain and valley breeze. Now you will only tell how mountain and valley breeze will happen. Imagine this is daytime. We have mountain chains and this is valley region. This is valley and this is mountain. Low, wait.
And then low.
Oh. Oh. We are not taking the top as such because the top will get it heated up during mid-noon times. After 12, yeah, we will take consideration of slopes. When sun is rising, these slopes will get heated up faster. Okay, compared to valley, which is at lower levels, the slopes will get heated up faster. The temperature at the slopes will be high. When the temperature is high, what will happen to the pressure? Low pressure. Here, the pressure will be high pressure. Hence, during daytimes, the wind will blow from high pressure region to low pressure region. Because this is flowing from valley, the name is given as valley breeze. When it flows from valley, it is known as valley breeze. Valley breeze is seen during daytime. We will notice valley breeze. Similarly, the reverse will happen during night times. During night times, the slopes will get cool faster because the land has that phenomenon of cooling faster. The slopes will decrease its temperature faster and they will experience high pressure zones, whereas valleys experience low pressure zones. The wind will blow from high pressure to low pressure, and this breeze is known as mountain breeze. It is also known as katabatic breeze because it is growing, coming like this. Okay, it is known as mountain breeze. Take down the heading seasonal winds. First one, monsoonal winds. Monsoonal wind is seasonal wind. Seasonal wind found especially in Asia. Found especially in Asia. Where ITCZ shifts ITCZ shifts and reverses its direction. Shifts and reverses its direction between summer and winter. Between summer and winter, and bringing heavy rainfall. Bringing heavy rainfall. Then land breeze and sea breeze. Second one is land breeze and sea breeze. It is better to make it a diagrammatic representation. You just mention day, write a land surface and a ocean or sea surface. Land and sea. During daytime, land gets heated up. Land ಮೇಲೆ temperature high ಅಂತ T ಮೇಲೆ ಬರೆದು T ಗೆ arrow ಮಾಡ್ಕೊಡಿ. T high, low pressure LP. LP. Whereas on sea you write temperature less, T less and high pressure. Draw a sea breeze moving from sea towards land. Give the direction of sea breeze from sea towards land. Put the arrow mark, which is very important, and mention mark it as sea breeze. Your sea is higher than your land. It is not at all possible. Sea level is sea breeze. The sea surface is always below the land level. Okay. While writing next one, land breeze, make sure you will write land is quite higher than the sea. Next, breeze. Yeah, breeze will flow just above the sea surface. They will not travel at the tropospheric level. Okay, they just travel above the sea surface. Then night, during night, same, similar land and a sea surface. Temperature on the land will be low, pressure will be high. Temperature on the sea is comparatively higher and pressure will be low. Draw arrow marks from land towards sea. Draw arrow marks from land towards sea and mention it as land breeze. It is moving from high pressure land to low pressure sea surface. Third important one, valley and mountain views. Valley and mountain views. Yeah, the same. Diagram only you will write. Rather than wordings, the diagram will convey more. Third one is mountain and valley and mountain views. During daytime, we have valley breeze. Daytime, the temperature on the slopes will be high, pressure will be low. In valleys, the temperature will be low, pressure is high. Draw air circulating from high pressure to low pressure region. During night, same, the reverse will happen. Here the temperature will be low, pressure will be high pressure. It will move from high pressure regions to low pressure regions. It is during night. It may look simple now, without revision you will get confused. When we are teaching, it may look simple. It will happen during day and it will happen during night. Just revise 2 to 3 times, it will get easier for you. Okay. Then majorly we have local winds. What are local winds? What might be the meaning of local wind? Wind. These are the winds which will present in particular locality. These are called local winds. There are 2 major types of local wind. One is hot wind, another one is cold. Okay, there are 2 major kinds of such local winds. I will show just a photo and I will just name few. You just Google something and mark them as cold winds and hot winds. Okay, because we are short of time. So, North America, we have a famous wind, local wind known as Chinook. Chinook is a winter or cold wind. It is located near the western margins of North America. Okay, Chinook. Just go through the names in few minutes. Nor'easter blizzards. Okay, this is also a cold type of wind. Then we have north. Okay, these are the North American local winds. In South America, we have one famous pampero. Okay, pampero. In Europe, we have many winds. Among them, some famous are Mistral, Fohn, Bora. Okay, among them, famous are Mistral, Fohn, Bora, and Levant also is quite famous. Then we have Africa. Africa, we have some local winds like Sirocco, Harmattan, which are famous. Kamsin, Sirocco, Harmattan, and Kamsin are the famous. When coming to India, we have one famous wind known as, which is not given here, it is known as Lu. It is a warm wind. Hot wind or warm wind. It is known as Lu. It is present near Rajasthan. Okay. After that, we have Russia. In Russia, we have one famous Buran. Buran and Kara Buran in Asia only. That Buran is in Russia. Then we have in Oceania or Australia, Brickfielder or Southern. Okay, these are the local winds which are present at particular locations. These are not like permanent winds which are very covering vast area. These are present in few regions of the world. One second. Tomorrow while coming, you just name few hot winds and cold winds, and also you have to mention the places. Okay, where are they? Are they in North America, South America, or which country? If, for example, for some important winds, the country is also important, because in South America we have one famous wind, Pampero. We should know where does Pampero is. It is in Argentina. Okay, in advanced classes you will get to know what are the importance of Pampero, Mistral and all. If your next teacher will teach that, you will get to know. Okay. Then like this, we have few hot winds, few cold winds. In exam, they will ask, they will give a group of 4 winds and they will ask which among the following is cold wind or hot wind. Jet streams. To be quicker, jet streams are nothing but upper atmospheric circulation. Upper troposphere, for example, above 9 to 14 kilometers. These are band of high speed waves. Jet streams, you just leave half a page for local winds. Half to 1 page for local winds, and you will write that while coming to. Okay, jet streams, these are nothing but upper atmospheric. In the upper troposphere, we will get some faster moving winds. These are known as jet streams. Okay. Apart from that, going into detail is not necessary now. Jet streams are upper atmospheric, fast moving winds. You just take down this. Located in the upper troposphere, about 9 to 14 kilometers. And these are bands of high speed winds. Bands of high speed winds. High speed. Speed also is mentioned here. High speed winds 95 to 190 kilometers per hour. More than your motorbike. Good. Then we have some important concept like cyclones. Simple definition, these cyclones are low pressure wind systems. Low pressure systems. These are nothing but low pressure systems. Among cyclones, we have 2 types. One is tropical cyclone. Another one is temperate cyclone. What is the meaning of tropical cyclones? Tropical. They occur near tropics. They occur near tropics between 5 degrees north or south to 35 degrees north or south. They occur in the tropical areas. Whereas temperate, above this region, above 35 degrees north or south is known as temperate cyclones. Okay, clear with this? Oh, tropical cyclones are formed Tropical cyclones are formed due to low pressure system. Whenever I say low pressure, it directly means that there is very high temperature. Where will we see a high temperature? In which latitudes we will find high temperature? 0 to near to 30 degrees. 0 to 30 degrees, we will find high temperature compared to other regions. In that area, we will find these low pressure belts. This brings rain. Okay, these are called as tropical cyclones. These temperate cyclones happens due to air masses. Okay. When I use such terms, I have to explain the terms. This happens due to air mass. Air mass is nothing but homogeneous mass of air. Homogeneous mass of air, which is covering a large area. Okay. How this happens, temperate cyclone, I will just take a 30 seconds to explain. See, there is a homogeneous mass of cold air coming. Okay. Imagine this is a mass of cold air. This AC air. Okay. This is cold air. Outer this door, we have hot air. Right. We have warm air. That air is homogeneous outside. We have same temperature outside this room. We have the temperature of 24 degrees here, which is comparatively cooler compared to outside air. When these two collide, they will form a front. They will form a front. Along the front line, we will get rainfall. Okay. Just think, when these two collide, when the cold air and the warm air collide, they will form a front. Along the front line, we will get what is called rain. Okay. How the front is formed? When warm air and cold air meets, which air will get uprised? Because of low density and high temperature, it will get rises up, whereas the cold air subsumes. Okay. In this region, we have formation of front, because warm air will rise up when cold air will get subsided down. This is called as frontal line. Along the front, we have frontal precipitation. Along the front, we have rainfall is known as frontal precipitation. The temperate cyclones occurs due to formation of frontal lines. Okay, these fronts will bring rainfall to the temperate regions. These are called temperate cyclones. Okay. There are many other differences. As of now, just know something which is important. Okay. Tropical cyclones occurs in 5 to 35 degree north and south, whereas temperate cyclones occurs above that region. Clear? Okay. In cyclone, we have many names given for cyclones, and also we have structure of cyclones. Am I able to cover that or not? I don't know. I have to do with oceanography also. Okay, this is actually the structure of tropical cyclone. Tropical cyclones are nothing but, have you heard of any cyclones like Amphan? No. If you read newspaper, the coastal cities, in devastations of coastal cities, you will get to know some cyclones names. Okay, recent one you have to learn after reading current. Okay, this is the structure of tropical cyclone. What I have to do, whether they will cover in advanced classes or I have to cover now? You wanted me to explain or to leave as such? Explain. Okay. Let us learn how these tropical cyclones develop. These tropical cyclones develop, for example, India. India is peninsula, right? Peninsula is nothing but 3 sides covered with water and 1 side is land. Okay, Indian peninsula, we have a sea called as here. Yeah, entire region is Indian Ocean, the sea. It is Bay of Bengal. The tropical cyclones originates when we have something called as pressure difference. It will originate in the regions where we have low pressure regions. First and foremost thing important for tropical cyclone to occur is intense low pressure system. How does we get low pressure systems? With high temperature. When the temperature is very high, and under such circumstances, we will get low pressure regions. Second and foremost important thing is to the formation of tropical cyclone, we need enormous amount of moisture. We need moisture. This moisture is provided by our seas. Okay, we need enormous amount of moisture that is provided by our seas. Then important thing is vertical wind shear. What does the meaning vertical wind shear says? Vertical wind shear. In vertical direction. A little bit of vertical movement should be there. Little bit of vertical movement should be there. That is known as vertical wind shear. Okay, that should be pre-existing condition. These three are very important pre-existing conditions for the formation of tropical cyclones. How the tropical cyclones look now? Let us move in detail to the how the tropical cyclones are formed. These are formed in the tropical regions because intense low pressure systems are seen in the tropical regions where the temperature is high. The region where the temperature is very high and the pressure is very low is called low pressure region. Okay. While there is something called as upward wind shear which helps for the tropical cyclones to develop upwards. They will rise upwards. While such rising upwards, they will condenses many amount of water vapors forming clouds. Okay. These clouds will not rain exactly at the center. The center of the cyclone is called as eye. Center is called as eye of cyclone, whereas the sides are called as cyclonic walls. Okay. They will not rain at the center because of intense low pressure system at the center that will create a halo at the center. They will rain in the periphery. On both the peripheral areas, they will rain. This region is called as rain band. The region up to where the rain occurs is called as rain band. Okay, this entire region from here to here, this is called as rain bands. For simple understanding, this is enough. The center is called as eye, whereas the sides are called as walls of cyclone, and the diameter up to where we can experience rains are called as rain bands. Have you understood? It is actually a deeper concept. We have to dig deeper, but I have to start with the oceanography. So this much is enough for now. Okay, the concept is same. You may get some more facts, that's it. The concept is same. The formation of cyclonic concept is same. Then how does cyclone dissipate? Or dissipate is nothing but, what can we say? ಹೆಂಗೆ ಕಮ್ಮಿ ಆಗುತ್ತೆ ಸೈಕ್ಲೋನ್ ಬರ್ತಾ ಇರತ್ತಲ್ವಾ ಮಳೆ ಯಾವಾಗ ನಿಂತ್ಕೊಳ್ಳುತ್ತೆ ಡಿಸಿಪೇಷನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಕಮ್ಮಿ ಆಗೋದು ಯಾವಾಗ ನಿಂತ್ಕೊಳ್ಳುತ್ತೆ see the cyclone when it is near the what we call near the sea it gets enough amount of moisture and it will be forming rains. Okay, when it moves towards the land surface, when it moves towards the land surface, it will dissipate. Why dissipation? Because lack of moisture. When it goes towards land, the moisture content reduces. Automatically, the cyclone will disappear. Okay, that is known as landfall. This phenomenon is known as landfall of cyclone. Okay, take down the heading cyclones. Just take the definition. Cyclones are well developed low pressure systems surrounded by closed isobars having increasing pressure outside and closed air circulation towards the center. One more thing you mentioned, these cyclones, next point, these cyclones blow counterclockwise, which is nothing but anti-clockwise. They blow anti-clockwise in northern hemisphere, anti-clockwise direction in the northern hemisphere, whereas clockwise direction clockwise direction in southern hemisphere. Because of which force? Why is the direction so? You are exactly right. The word you missed, Coriolis force. Okay. Because of Coriolis force, cyclones are anti-clockwise in northern hemisphere and clockwise in the southern hemisphere. Then you take tropical cyclones. Otherwise, you just make a tabular column of tropical cyclone and temperate cyclone. Tropical, temperate. Tropical cyclones and temperate cyclones. Have you understood the concept between tropical and temperate? You just, while coming tomorrow, just make 3 to 4 difference. You just Google it and write down 3 to 4 difference between these. Oh, that sends your out. Another thing, these cyclones have different names around the world. In North American continent, they are called as hurricanes. Okay. In China, Japan, they are called as typhoons. Whereas in Indian Ocean, they are called as cyclones. In Australia, they are not given the name. They are called as billy-willies. Australia, they are called as billy-willies. You mentioned these also for Group C exams. They will directly ask them match the following. In North American continent, these are called as, in Atlantic Ocean, these are called as hurricanes. Whereas in South China Sea near Japan, they are calling as typhoons. In Indian Ocean, we call them as cyclones. Whereas in Australia, they call them as willy-willies. Okay, the main characteristics, temperate cyclone. Okay, this is the difference, anticyclone. So let us end here. This completes your, like this, the question will come. The local winds. Chinook is a local wind in where? Sirocco is the local wind where? Lu is the local wind where? Fohen. Like this, they will get match the following so that you just make the list of winds and whether it is a hot or cold wind and which country it is flowing. Okay, the country where it is originating. Oh, can you able to solve this? You want me to read? Option A. In cyclonic pressure system in the northern hemisphere, wind blow in anti-clockwise direction. Option A. Then tropical cyclones in Atlantic is called as typhoons, typhoon, hurricane, willy-willies. Atlantic is nothing but North American and South American region. Option D, typhoon. No, it is hurricanes in North American region. That is called as hurricanes. Okay. This completes your climatology as of now. Let us start with oceanography after a break. Okay. Last concept in climatology is climate. World climate. World climatic regions. Which is majorly first for layman's understanding, the world has been divided into three groups, three climatic groups. First one is, which is this zone known as, no, around equator. Around the equator, what the zone called as tropical zone. Below and above the tropical zone, we have subtropical zone and we have temperate zone. This is the grouping done by Greeks for their understanding in simple terms. Okay. Then we have a scientist called as Cooper. This is first basic understanding and basic division of world climate. Then we have a scientist named called as Köppen. He classified the world into 5 major groups of climate. He classified the world into 5 major groups, and in 5 he have given the name A, B, C, D, E. And later on he will added subgroups to A, subgroups to B. Okay. Then there are umpteen number of groups, world climatic groups. This is the Köppen's classification. Okay. Köppen first classification. Classification A is tropical humid climate, where we experience high temperature, high rainfall. That is known as tropical humid climate. It will fall around equator. Okay. In tropical humid climate, he has divided into tropical wet, tropical monsoon, tropical wet and dry climate. Okay. Then we have dry type of climate. Dry type of climate is nothing but your deserts, hot and cold desert. Okay, be it hot or cold, both deserts comes under dry climates. In dry climates, he divided again into subtropical steppe, subtropical desert, mid-latitude deserts, mid-latitude steppe, and mid-latitude deserts. So further, he classified the dry climate into 4 types. Later on, he has classified into warm temperate. Temperate regions, we have some places at some places, even in temperate zones, we have warm condition. Wherever we experience warm condition, we will get good amount of precipitation. In that, you have humid subtropical, Mediterranean, and marine west coast. Later on, D, he classified into cold snow, where you have humid continental and subarctic regions. And last one is E, which is nothing but cold climate. In cold climate, we have tundra and polar ice climate. Later, you will added one more climatic division, which is H. H is nothing but highlands, something which has high altitudes like mountains. This is called as highlands. Highlands have climate in lower lying areas. It has equatorial climate. When it rises, it has temperate climate. Okay. This is the major overview of classification given by Köppen. It should be dealt in detail. It takes more time. It takes around 2 hours to deal all this classification. It will be done in your advanced courses. Okay. At least you just know there is something which is missing now, that is not Köppen's classification. Okay. In that, the very important one is steppe, savanna, Mediterranean climate, and monsoonal. These are very much important for your exam perspective, and the questions will come from them. Saying so, let us move quickly to oceanography. This is the third major segment in our physical geography of world. First, take down what are the topics we are going to deal in oceanography. What does oceanography mean? Study of oceans. In that, first we will study the structure of ocean. That is nothing but structure of ocean surface. Okay. First, we will study bathymetric study of ocean surface. Or we can say oceanic relief features. First one is oceanic relief feature. Later on, we will study about ocean water movements. Ocean water movement. In ocean water movement, we have two types of movement. One is vertical, another one is horizontal. Then we have oceanic temperature distribution. Similarly, ocean salinity distribution. These are the major concepts we will cover under oceanography. Okay. Lastly, we have one more important concept, that is corals. Ocean, we have a special creatures called as corals. We will discuss about corals and their distribution. What are the necessity for coral development? Okay. This is the overview of oceanography. I think we have left with 1 hour 15 minutes from now. We can cover these two. As per my knowledge, we can cover these two. If possible, I will touch these two also. Otherwise, it will be covered in your next class. Okay. First, let us know how will be the oceanic water. It is salt. How the salt may be measured? What may be the unit to measure the salt? No?
Because of the heat it produces.
Because of heat, it produces salt. Okay. Because of heat, evaporation will happen. So the salt will get concentrated. Okay, that is fine. What may be the unit to measure the amount of salt present in any kind of water, be it oceanic water, be it fresh water? Salinity is a term, a definition term. What may be the unit? Don't know. Salinity is measured by unit called as parts per thousand. Parts per thousand. What does it say? It says if you take 1,000 ml of water, 1,000 ml is nothing but 1 liter. If you take 1,000 ml of water, how many ml is the salt present? How many part of it is the salt present? Salt seed. If, for example, you will add 5 gram of salt to this 1,000 ml of water, it will form 5 parts per thousand. It is represented as this seed. Okay, this is the symbol of parts per thousand. This represents the salinity of the given water. Okay, what is the unit of salinity? It is parts per thousand. 1,000 is represented like this. Percentage plus one more small zero. Let us first understand oceanic relief features. Let's now understand what are the major features of oceanic, what is called oceanic land or ground. Okay, first we have land here. From land, when we travel towards any sea or any ocean body, we will have a gentle slope, at the starting. Before entering the sea, we will notice a gentle slope. Up to here, this is called as continental shelf because it is extension of continent before reaching the oceanic layer. This is known as continental shelf. There is a gentle slope, not the slope is not too much visible, but we can observe a little bit of sloping towards the ocean. Then we have sudden or abrupt slope before entering the ocean floor. There is like your seesaw. Your seesaw, there is an abrupt slope at the second region, which is we call it as continental slope. The second important thing is continental slope, where we will see enormous amount of steepness. Okay, the sudden steepness will come. This is known as, this region is called continental slope. After continental slope, we have some planar regions even in oceanic deeps. Planar regions. What are the three major landforms we studied the second day? Three major landforms. After plate tectonics theory, we covered landforms. In that, three major landforms. One is geomorphology. In that chapter, we covered three major landforms. First one is something which has high elevation. We discussed. Good.
Mountains.
Mountains, plateaus, and plains. Similarly, in ocean also we have a planar region. These planar regions are called as abyssal plates. What are the planar regions of oceans are called? These are called as abyssal plains. Then we have small hill-like creatures even in oceanic grounds. These hills are called as, one is called as sea mounts, and another name is gyres. Okay, just know the terms, later you will write the definition. Once, if the top is sharper, it is called sea mount. If it is blunt, it is called as gyre. Okay. Similar to our hills and mountains, we have sea mounts and gyres. After this, if these mountains, if they reach the top, sea level up, if they reach the sea level, if a part of it is visible above the sea surface, it will form our islands. What are these features which are visible above the sea surface is called as islands. These are nothing but our mountains only. These are top mountains which will grow beyond the sea, MSL, mean sea level. Okay. Then we have something, this is then we have something called as trenches. Trenches are nothing but deep points. Ocean floor, in ocean floor we have some deep points. These are called as trenches. Okay, trenches. While dealing with plate tectonics theory, while dealing boundaries, in some boundary I have mentioned trench. Which boundary? When continental plate and oceanic plate converge, we will see some formation of trenches, where at the junction of, yeah, that is the trenches. Okay, trenches are deep points. This is our first oceanic relief features. They are not like normal lands. They are known for its elevations and different relief features. First one is continental shelf. Second one, slope. Third one, abyssal plains. Then we have seamounts, gyres, and islands. Lastly, we have few of the trenches, which are deep points in the ocean. Have you understood this? Before writing that, here is a concept. Just know what is hydrosphere. Hydrosphere is nothing but the sphere which contains water. How much of Earth, what percentage of Earth is covered by water? It is about 3/5, 3/5 or nothing but around 71 to 75. Previously it was 75%, now it is decreasing, it is 71%. Then give this heading. Oceanic relief features. Take down this diagram, similar to what I have drawn this. Abyssal plains, oceanic ridges, seamount gyres, trenches, fill water level. If above that water level land is appearing, it is known as islands. Okay. First, continental shelf. How we define continental shelf? It is nothing but a shallow submerged layer which connects continent and ocean floor. Okay, take down. Continental shelf. This is shallow, submerged, extension of continent. Next point, the depth ranges from 120 to 130 meters. These continental shelves have too much economic importance to man. These are very much economically important to man because one, they are rich in minerals. They are rich in minerals. Second one, they are greater fishing zones. They are rich in minerals. They are also greater fishing zones of the world. Then we have continental slopes. These are continuous sloping portions. These are continuous sloping portions of continental margins. Extends to the depth of 180 meters to 3,600 meters. Then we have abyssal plains, because 3,600 meters. They are abrupt. Suddenly they will slope. Then we have abyssal plains. These are extremely flat. These are extremely flat, featureless plains. Featureless plains. In the abyssal plains, we have smaller relief features. First one is seamount. This one. Seamount. Seamount is a mountain. Seamount is a mountain with pointed summits. I think they have sharp tops. Here it is in simple form. The seamounts have sharp pointed tops. Sharp pointed tops. You want me to repeat the previous sentence? Seamount, pointed tops. Just make it short form, pointed tops. Guides. One is guides. G-U-Y-O-T-S. Guides. These are flat top seamounts. See, this is known as seamount. This is known as guide. These are flat topped seamounts. See, flat topped seamounts. Another name for guide is table mounts. These are also called as table mounts. Now tell me one thing, how these guides and seamounts are formed? What may be the reason for formation of such mountains inside the
Sedimentation.
sedimentation? Okay. What will you say? What may be the reason for the formation of these guides, seamounts, islands? How they are formed? There is the answer in the board only, in the diagram only. Huh? I can't hear you because of? Yeah, exactly right. Because of rise of magma. That is nothing but because of volcanic eruption, you will get these creatures like mid-oceanic ridge, islands, guides, and seamounts. It is not because of sedimentation, because if the shoreline and waves bring sediments, it will spread over the abyssal plains. Okay, it will spread over the abyssal plains. Year after year, the thickness of planar sediments will increase. Sedimentation of the ridges.
The stones, modern stones of the land, when they sediment.
Okay, that is not called as sedimentation, that is known as solidification. When the magma comes out, due to cooling effect, it will get solidified. Sedimentation is something which is the small rocks being carried by any agent, be it water or wind. Okay. Primary reason for formation is just your volcanic eruption. When volcanoes erupt, they will form ridges. Ridges are nothing but chain of mountains. Ridges is nothing but a chain of mountain. Among the ridges, if it is having a sharp top, it is called a seamount. If it is having flat top, it is called guides. If it rises above the mean sea level, it is called as islands. Then you have submarine trenches or oceanic trenches. Last one, submarine trench or oceanic trench. These are deepest parts of ocean. These are deepest part of the ocean. World's deepest point is Mariana Trench. The Mariana Trench is the deepest trench in the ocean. Mariana Trench is the deepest trench in the ocean. It is a part of Pacific Ocean. Near Philippines, we have Mariana Trench. It is a part of Pacific Ocean. Clear? In advanced classes, you have to learn this one. There are many ridges. These are ridges. There are many ridges. You need to know the name of these ridges. These are ridges, and you have to learn some of the trenches too. These are trenches. Japan, Mariana. Okay, these are the trenches. You need to learn world major trenches and major ridges in the ocean. Okay, during your advanced classes. For the reference, this is Mariana Trench in the Pacific Ocean, which is the deepest. It runs for about 11,000 kilometers, 11,000 meters deep in the. Then you have moments of oceanic water. In that, we have two major kinds. One is vertical motion, another one is horizontal motion. What is vertical means? Vertical means rise in height. Okay, vertical is nothing but rise in height, whereas horizontal motion is just surface motion. What may be the example for vertical motion? What may be the example for horizontal motion? You have seen the beaches, right? You have visited the beaches, Goa. Hmm? No. Any beach, any other beach, Mangalore, Malpe. No. Just think over what maybe some. There are examples for both vertical movement of water in the ocean and also horizontal movement. This is a regular phenomenon, so I am asking. Just think for 1 minute. You will get to it. Good. Waves. Waves is an example. Then one more you can say.
Water currents.
Good. Water currents. You are left with only one.
Tides.
Hmm?
Tides.
Good. These are the major classification of ocean water movement. Just take down this. Then I will explain how they are. Okay. Moving is simpler one. First one is waves. Whenever you travel to any beaches, something which approaches you and something resides. These are known as waves. Wave is actually not the movement of water as such, but wave is something where the energy is moving in a particular direction. This is nothing but energy. This energy is provided by wind. How are waves formed? Waves form due to the movement of energy, that is wind. Okay, this wind will provide some amount of energy for the waves to move in particular direction. This is simple. This is an horizontal movement. There is nothing much to deal. In these waves, we have two types. One is trough. Trough is nothing but something which is residing. One is crust, which is rising. We have two technical terms in the waves. One is trough, another one is crust. Okay. You should know for your statement based question, you should know something. Waves is not actual the movement of water, it is movement of energy inside the water. There is nothing much to deal in waves. Second, an important one is tides. What do you mean by tides? Tide. Rise and fall in water level. Due to that rise and fall is normally water movement. This tides occurs because of some attraction forces. That is gravitational force. So, how do tides occur? Because of gravitational force of moon and sun. Okay. In tides, we have two types of tides. One is flow tide, another one is ebb tide. Flow tide is also called as flood tide. Just listen, later you can write. What is the reason for formation of tides? Gravitational force of moon and sun. There are two major kinds of tides. That is, one is flow tide, another one is ebb tide. What does this flow tide and ebb tide mean? Say this is your coastal, any city near the coast region. During full moon day, imagine this is full moon or the new moon day. During full moon day or new moon day, this water level will get attracted towards moon gravitational force and it will rise its height. Due to moon's gravitational force, the water will get attracted, quite attracted. But in the ocean, we have enormous amount of water. This is visible as huge increase in height, okay, near the shore levels. During full moon day, it will get majority of attraction is seen in the full moon day. It will get attracted and rises the level of water. Water level rises and it will form something known as flood tide. This rise in water level is called as flood tide. Okay. After few quarters, the moon will rise and fall every 30 days, right? The moon, full moon day and new moon day, we will observe every 30 days. After a quarter, this moon will, like full moon will become half moon, right? Half moon. It will become half moon. Then the attraction force, the gravitational force decreases and the tidal level decreases. Think this is mean sea level. When the flood tide occurs, the sea level reaches this height. This is called as increase in sea level, that is called as flood tide. and the decrease in sea level is called as ebb tide. What is ebb tide? Decrease in sea level due to less attraction by moon or sun. Okay. Tides are majorly caused due to which force? Gravitational force of moon and sun. Okay. Let us understand the types of tides now. Two major types of tides, how tides occur on the earth. First, before going to types, first understand how tides occur on the earth. This is Earth. Okay. We have moon. Surrounding the earth, we have 70 to 75% of the water. On the earth, how much percent of water we have? Okay, this is the water surrounding the earth. Okay. Due to moon's attraction forces, one side we will get increase in height of this water level. One side of the earth experiences rise in water level due to attraction of moon, that is moon's gravitational pull. That gravitational pull will attract the earth's oceanic water and it will be visible as rise in sea level. It is called tides. Okay. Whether the other side will remain silent or it will also expand. It will also expand its height. What happens to the other side? It remains silent. What do you say? ಇಲ್ಲಿ ನಿಮಗೆ ಟೈಡ್ ಕಾಣಿಸ್ತಾ ಇದೆ ಅಲ್ವಾ, ಟೈಡ್ ಬಿಕಾಸ್ ಆಫ್ ಮೂನ್ ಅಟ್ರಾಕ್ಷನ್, ಮೂನ್ ಗ್ರಾವಿಟಿಯಿಂದ ಇಲ್ಲಿ ಟೈಡ್ ಆಗಿದೆ. ಇನ್ನೊಂದು ಸೈಡ್ ಅಲ್ಲಿ ಟೈಡಲ್ ಬಲ್ಜ್ ನಮಗೆ ಕಾಣಿಸಲ್ವಾ? ಓಕೆ. Before saying whether it is visible or not, let us understand something. Imagine you tied a ball to a rope and you are keeping it at your hand. Okay, don't change your hand's direction, just spin it around. Okay, don't move your hand, keep it constant, just spin it around. While spinning, it will move in a circular fashion, right? It will move in a circular fashion. After 2 to 3 rounds, you just stop spinning the ball. Still, it will continue rotation or not? It will continue rotation. While that continuation of rotation is due to one force that is known as which force? No, not rotational force. When the ball is spinning, we observe two kinds of forces. One is acting inwards, known as centripetal force. Have you heard of this? Centripetal force. One is acting inwards. Between your hand and thread, one force is acting inwards, which keeps the ball at a constant distance from the hand. This is known as centripetal force. Another force will act in opposite direction, because for every force there is an equal and opposite reaction. Have you heard of this statement? Another force will act in opposite direction, that is known as centrifugal force. What is this called as? Centrifugal. Centrifugal force, that is acting opposite direction to the spin of the ball. Okay. First one is centripetal force, which is acting inwards, whereas centrifugal force acting outwards. This is the basic concept. Even this concept is applied in our tides also. We all know Earth is a rotating body. Is Earth rotating? Is this rotating around which star? Sun. It is rotating around the sun. Yeah. Similarly, Earth is our ball. In this experiment, we took ball. Similarly, Earth is ball. Now, it has an opposite reaction to this tide generating force, that is known as centrifugal force. The opposite force to this tide is centrifugal force that will cause tidal bulge in the other side of the, okay. What is the reason for this? Centrifugal force. Is the concept clear? How tides are formed? This is tidal bulge is seen. This bulge is called as tidal bulge. Tidal bulge is seen due to attraction by the moon's gravitational pull. Another side, tidal bulge is seen due to centrifugal force of the earth. Okay. Any rotating body, it exhibits both tidal force. One is centripetal, another one is centrifugal. This centrifugal force is an opposite acting force which is helpful for the generation of tide at the other side where moon is not present. It is equal. The bulge here and here are equal because here we have gravity, other side we have centrifugal force. Okay, the concept of tides are clear. Now let us understand the types of tides. Basically, we have two types of tides. One is spring tide, another one is neap tide. There are types of tide. How is the sense? In the shore level, the increase in sea level is called as flood tide. Okay. Decrease in sea level is called as ebb tide. Types of tidal waves are what we call the increase or decrease in mean sea level. That is called as ebb tide and flood tide. Okay. The actual types of tides are spring tides and neap tide. This is major type of tide. That is actually in tide we have two waves. That is ebb tide and your flood tide. Okay. Now let's listen here. How the spring tides and neap tides are formed. First we have Earth. Okay. Earth is rotating around. We have Sun. Okay. If Earth, Sun, Moon is rotating around the Earth, is it right? Moon is rotating around the Earth. If Moon, Earth, and Sun are in the straight line, either Moon can be here or here. Okay. When Moon is at this point, what will be the Moon? Is it full Moon or new Moon? When Moon is near to the Sun, between Sun and Earth, is it full Moon or new Moon? New Moon. Another side, full Moon. Okay. When Moon, Sun, and Earth are in the straight line, what happens to the gravitational pull? Let us assume one by one. Here we have Earth. Think here we have Moon. Before going to there, here we have Moon. The Moon is attracting Earth's water. We have tidal bulge. Okay. Similarly, Sun is also having some amount of gravity. Does Sun have some gravity? Yeah, because of Sun's gravity, we are placed at the orbit. Due to Sun's gravitational pull, we also see something bulging here. Both Moon and Sun push the Earth's water in a single direction. Okay. We have a large tidal bulge. We have a large tidal bulge seen when Moon and Sun are in the same direction. Okay. After 15 days, we see change in position of other side of the tide is happening because of centrifugal force. Okay. After 15 days, we see Moon at this junction. Now, Moon has gravitational force that is attracting the Earth's water. Similarly, Sun's gravitational pull also is attracting the Earth's water. We get tides. These tides when they are in straight line, do we get a maximum amount of tide or a minimum amount of tide? Do we get high tides or low tides? We get very high tides, and these tides are called as spring tides. Spring tides are formed when these three bodies are in straight line. Just learn this. Yes, and it's spring tides occurs when the sun, moon, and earth are in straight line. Okay. Later, I will give you notes. Don't worry. We just have 45 minutes. So, listen. After first quarter, the moon will move in this direction. The sun is here. The moon is here. Then the moon's gravitational pull attracts Earth's water and it will cause tidal bulge. Here, because of centrifugal force, we will get tidal bulge. Here, sun is also attracting. We get some amount of small tides here and here. Okay. Compared to this tide, whether the tidal bulge is high or low. Compared to this tide, in spring tide, the neap tides caused during the first quarter and the last quarter, it's comparatively less. And these tides are formed when sun, moon, and earth are exactly at right angles to each other. They are at right angles, right? They are at 90 degrees or right angles. At such condition, they will form tides. These are called as neap tides. Okay, neap tides. Clear with this concept? Then we also have another type of tide based on duration of tides, that is diurnal tides, semi-diurnal tides, and all. Okay, while giving the notes, I will dictate. That's it. Take down waves. First one is waves. Waves are nothing but oscillatory movements that results in rise and fall of water surface. Rise and fall of water surface. They are energy. They are the energy, not the water as such. They are the energy, not the water as such. As such, S-U-C-H. Yeah, as such. The energy for the waves is provided by the wind. The energy for the waves is provided by the wind. In waves, we have two, no? One is trough, another one is crest. Trough is formed due to wind, movement of wind, whereas crest is formed due to gravitational pull of earth. Okay. Then we have tides. Tides are periodic rise and fall. Tides are periodic rise and fall of sea levels. caused by combined effects of gravitational forces exerted by sun, moon, and rotation of the earth. And rotation of the earth. In bracket, you write centrifugal force. Centrifugal force. Oh, one more thing I need to ask you. Among sun's gravitational pull and moon gravitational pull, which is more attractive for the earth? This is moon and this is sun. Which gravity attracts more amount of water? Sun, according to you. Sun. I will say it is moon. Why it is moon? I will say it is moon's gravitational force that attracts more amount of water. Yeah, that's why I rubbed and right nearer to that. Okay. Moon is very much near, very much closer compared to sun. Hence, moon's gravity will attract more amount of water rather than sun. Sun has more power, but sun is far away, which is about millions of kilometers. But moon's distance is not that much high. When something is far away, the effect will decrease, right? That's why moon is comparatively very nearer to the earth. Hence, the gravitational pull of moon is more pronounced than sun. Flood tide and ebb tide. Flood tide is a rising tide. Flood tide is a rising tide or incoming tide. It is tidal motion, types of tidal motion. Flood tide is rising tide or incoming tide, which results in high tide, Then ebb tide. Ebb tide is receding or outgoing tide. Receding or outgoing tide. Then types of tides. Based on, first one, based on position of moon and sun. First one, type of tide based on position of moon and sun. In that, neap tide and spring tides. Are you able to take this diagram? It's simple, no? Draw sun. When moon is in the center of sun and earth, it is known as new moon because it gets shadow, and it is known as new moon. When it is far, it is known as full moon. During new moon time and full moon time, we have spring tides. Then second, spring tide. When sun, moon, and earth are in straight line, the height of the tide will be higher. This occurs twice a month. This occurs twice a month. One during full moon day or Purnima, and the other in new moon day or Amavasya. It occurs twice a month. One during full moon day and another during new moon. Next we have neap tides. Neap tide. Normally after 7 days of a spring tide. Normally after 7 days of a spring tide, when sun and moon become at right angle to each other, we see neap tides. Next point, neap tides are generally lower than spring tides. Neap tides are lower than spring tides because gravitational force of sun and the moon, gravitational force of sun and the moon counteract one another. Gravitational force of sun and the moon counteract one another. Okay. Then types of tides based on frequency of occurrence. Second major types of tides based on frequency of occurrence. Okay. How these tides are formed? For example, here in Gulbarga, imagine Gulbarga is a coastal city. Imagine Gulbarga is here. We have coast lining along Gulbarga. Okay. If when we see diurnal, semiurnal, how can I tell? Okay. During 6 o'clock, how much amount of moon we can see? During 6 o'clock. Is that visible? A bit. At 7, at 8, are quite large. At 9, okay. Yeah.
It was morning session.
Evening 6. Okay. At 9, 10, 11, 12. At 1 o'clock or 2 o'clock, you will get a visible portion of moon. Okay. During night times. In full moon, at 9 only, you will get majority portion of the moon visible to our eyes. Okay, when such differences occurs, when there is high visibility of moon, we get high tides. Okay, in a day only we will get high and low tides. When moon is not much visible, we get low tide. When moon is highly visible, we get high tides. Based on duration of tidal variation in a day, we get these three kinds. One is semi-diurnal tides. According to these tides, semi-diurnal tides, we get two high tides and two low tides each day. In a day, we get two high tides and two low tides. Diurnal tides, in this type of tide, only one high tide and only one low tide. In 24 hours, we will get only one high tide and one low tide. Mixed type of tides, there is variation in height which is not as prominent and visible as like high tide, and variation happens day to day. Okay, this is based on frequency of tidal occurrence. That neap tide and spring tide which we have studied, they occur every quarter once, every 7 days once. Okay, 7 days once we will see spring tide. After spring tide, after 7 days we will see neap tide. It is a monthly phenomenon. It is a daily phenomenon. Take down based on frequency. First one, semi-diurnal tide. Because moon takes 24 hours to rotate the earth. That's why we. Semi-diurnal tide, these are most common tidal pattern. These are most common type of tidal pattern. Featuring two high tides and two low tides in the same day. Featuring two high tides and two low tides in the same day. Next, you have diurnal tides. There is only one high tide, diurnal tide, only one high tide and one low tide each day. Then we have mixed tides. Mixed tides. Tides having variations in height. Tides having variation in height are known as mixed tides. After understanding tides, why do tides are important? What is the importance of tides? What may be the significance of tide? Okay. Last one more concept. What may be the significance of tide? Why we need tide? What is the importance of tides? Sorry, to
Balance the
balance the water. Okay. Other than that,
water and absorption.
good. It is helpful for generation of electricity. Okay. Then good. Solar power, it is different. Electricity. Okay. Tidal electricity. Anything extra? When tides occur, for example, this is India's peninsula. Imagine the tides are very much visible in the narrow belts. Where we have broader areas, tides are not visible because of area is larger. The height of tide will visible only little bit. When we have narrower regions, the height of tide will be very high. The visibility of tide will be very high. In such cases, the tidal height were very high. When the tide is very high, they will help for navigation. First and foremost importance is navigation. What is the importance of tide? They will help for navigation. For example, when the tidal level is low, the shippers, when they are sailing, they feel the difficulty to sail. due to tide, because of tide, they naturally increase the water level, which helps them to sail easily towards the coastal region. One is navigation. Second one is because of this flood tide and ebb tide. When flood tide occurs, it will enter the coastal region. When ebb tide occurs, it will reside from the coastal region. Such tides will help for bringing and settling of sediments or mixing of sediments. Second important significance of tides is sediment mixture will happen. These sediments are very much important for fishing. What will fish eat? Fish will depend on phytoplanktons and zooplanktons. That zooplanktons and phytoplanktons will depends upon sediment. So the sediment mixing will happen because of tides. First one important is navigation. Second one is fishing. Third importance is whenever we get tidal forces, we can generate electricity. That is tidal energy. Okay, third important significance is tidal energy. Okay, this covers your tides. Okay. Before ending tide, based on magnitude of tidal occurrence, we have something which you need to learn: perigee and apogee. Okay, this is Earth. The center one is Earth. Moon is revolving around an orbit around the Earth, right? Because the orbit is in elliptical shape, at some times Moon will be nearer, very nearer to Earth. At some position, it will be very far from the Earth. Is this visible in this diagram? Moon will appear at some position, it will appear nearer to the Earth. At some position, it will appear far from the Earth. When it is very close to the Earth, such times we call it as perigee. When it is seen as a bit closer to the Earth, it is called as perigee. Okay. When it is far from the Earth, it is called as apogee. Okay. Now tell me, during which time we will get maximum amount of tide? Maximum rise in tidal height? During perigee or apogee? Yeah, during perigee, when Moon is very close to the Earth, we will get super tides. Clear? Okay. Now you have another concept. You just take down the diagram. It can tell many words. Perigee is something where it is nearer to Earth, Moon is nearer to Earth, whereas apogee is something when its Moon is far away from the Earth. Okay. Similar to that, Earth is revolving around which body? Earth is revolving around Sun. Okay. Here we have Sun. When Earth is revolving, the distance between Sun and Earth is 150 million kilometers. This appears due to elliptical orbit. It appears closer at some times. This is known as perihelion. Helion because Sun is known as helion. Okay. When Earth is very close to the Sun, it is known as perihelion. When it is far away from the Sun, it is known as aphelion. Okay. Just take down perihelion and aphelion along with this diagram. Perihelion occurs during January. In the month of January, January 3rd, you will get perihelion, whereas aphelion occurs in the month of July, July 4th. Date, around July 4th.
Exactly on the date.
Yeah, because we have 365 days. That may vary 1 or plus or minus day during your leap years. One is perihelion and one is epihelion. Perihelion is the nearest position. Epihelion is far away position. Okay. When we get maximum times during perihelion and perigee. Okay. When Sun and Earth are in perihelion position and Moon and Earth are in perigee position, we get super high tides. When we'll see super high tides, when Moon is at its perigee position and Earth is at its perihelion position, the gravitational attraction will be very high and we will get very high tides. Okay, that is the significance of position where Sun, Moon, and Earth are placed. Okay, let us complete at least ocean currents for today. Ocean currents are nothing but these are large scale movement of surface water. Just listen, later you can take down. Ocean currents are large scale movement of surface water. This is very much important. These are not underwater. This is just a surface water, superficial water will move. Okay. How these ocean currents generated? What are the reasons for ocean current generation? What might be the reason? These are horizontal movement. As first we discussed, vertical movements are completed now, waves and tides. Now we are dealing with horizontal movement. That is nothing but they just slide. What might be the reason for ocean currents occurrence? What may be the reason for formation of ocean currents? They are moving like this. They are moving horizontally. What may be the reason? Good. Winds. Okay. Next. Guess anything. If it suits, let me take. Sorry? Waves. No, waves is not a reason for ocean currents. These are large scale movement. Entire specific ocean water will circulate in a certain fashion, certain direction. Heating by the sun. Sun's heating. Yeah. When the heating is high during daytimes or when they are nearer to, when some oceans which are nearer to equator and 23.5 degree north and south, they will get intense amount of sun's rays. Heating will be high. They will generate warm currents. What they will generate? They will generate warm currents. Similarly, here the heating is very low. We will get cold currents. Okay, now. And the third important is gravity. Okay. Whereas gravity higher and lower, the gravity will vary from 0 degree or equator towards the poles. This is also one of the major factors for the directional flow. Then and last, we have something called as rotational force of Earth is known as which force is now caused due to rotation of the Earth. Yesterday I told you. The force generated due to rotation of the Earth. Force generated due to rotation of Earth. During cyclones also, we discuss cyclones or anti-clockwise in the northern hemisphere due to that force. Good. It is Coriolis force. These are the primary force for the generation of ocean currents. What are the primary forces which are necessary for ocean currents to be generated? Winds. Coriolis force. These are very much important for the flow, directional flow. This is important for the nature of the ocean current, whether it is warm or cold current. Based on heating, we have two currents, warm and cold currents. Let us learn few of the important oceanic currents present in the world. Warm currents, they originate in the equatorial region, whereas cold currents originate in the polar region. Now you tell me, we have warm currents here. We have cold currents here. Will the warm currents and cold currents meet or not? No. No. They won't meet. Yes. Will they meet? They won't meet. Will they meet? They meet. Actually, these ocean currents, the significance of ocean current is to redistribute the Earth's heat. Redistribution of heat is one of the phenomenon or purpose of the ocean currents. What will ocean currents? They will flow in certain fashion, like the warm currents wanted to meet the cold current, whereas the cold current wanted to meet the warm current and redistribute the heat in the earth. Okay. See, now let us learn few of the major ocean currents of the world. Some first I will take like what? Ocean wise. Okay, let us learn ocean wise. Which is this S-shaped ocean? S-shaped ocean which is present between North America, South America, Africa and Europe. How many oceans do we have? Mahasagaragalu eshtiದೆ? How many major oceans we have? How many oceans do we have? We have 7 continents. Do you agree with that? Okay, how many oceans do we have? 4. We have 5 major oceans. Okay, we have 5 major oceans. Starting from north, we have Arctic Ocean. This is Arctic Ocean. Second one is between North America, South America, Europe and Africa, we have Atlantic Ocean. Then we have largest ocean, Pacific Ocean. Pacific Ocean is cut, okay, because of formation of map 2D diagram, we have cut at the center of Pacific Ocean. Later we have, which is this? Indian Ocean. Last one is, okay, Antarctic Ocean. Majority of our land is surrounding this Atlantic, Pacific and Indian Ocean. So we will deal these 3 oceans and oceanic currents. Here the currents are not such prominent because of ice. Okay, ice. There, the oceans are frozen and the currents are not prominent in Arctic and Antarctic region. Okay. Let us learn from Atlantic Ocean. Just listen. Later on, you can mug up the things or you can understand now. We have equatorial current. First, this is the region where we have equator. Around the equator, we have equatorial current. Equatorial current is always warm current because we get higher amount of sun's rays falling near the equator. It is a warm current, so I am representing in the red line. It is traveling from east to west because of Earth rotation. Earth rotates from west to east. It is traveling from east to west because of rotation of the Earth. Okay. Then it will turn and take a bend due to coastline. Here we have coastline. No, it will hit the land and it will turn and take a bend and it forms a stream called as Gulf Stream. Here, anything which is the water body, which is called as Gulf. Okay. The coastline is called Gulf. Here we have Gulf of Mexico, so the name Gulf Stream. Okay. After hitting Gulf Stream, it will transform into, it will drifting. Drift means moving northwards, hence the name is given as North Atlantic Drift. As the ocean name is Atlantic, it is moving, traveling towards the north. The name is given as North Atlantic Drift. Okay. After this, North Atlantic Drift will enter the European continent. There we have a country called as Norway here. A country called as Norway. Hence, the name given to this warm current as Norwegian warm current. Okay. In Atlantic Ocean, we have warm currents. First, learn about warm current. First one is equatorial warm current. It will turn into Gulf Stream. Later, Gulf Stream will turn into North Atlantic Drift, which will later turn into Norwegian current. Okay. Then, from polar region, the cold current will come in. That cold current, we call it as Labrador current. What is the cold current? Named near Greenland, we have Labrador cold current. Okay. This Greenland, if this is the Greenland, this country, we have Labrador cold current. It will come and it will enter near Africa. We have a city called as Canary here. Canary in Africa. There the name is given as Canarian cold current. Okay. Now can you tell in a circular fashion what are the warm currents and cold currents in the northern Atlantic Ocean? First one, equatorial.
North Atlantic, the Norway, it becomes North Atlantic warm current.
Okay. Cold currents, two cold currents, namely Labrador and Canarian cold current. Okay. In the similar fashion, in the southern hemisphere, we have south equatorial warm current. Below the equator, we have south equatorial warm current. It will touch the nation Brazil here and it will form Brazilian warm current. When it touches the Brazil, it forms Brazilian warm current. Similarly, from Antarctica, we have cold current coming. It touches a city in Africa called Benegula. It is called as Benegulan cold current. What is the cold current named? Benegula cold. Is this clear? This is entire of your Atlantic Ocean. We have few warm currents and few cold currents. Then Indian Ocean. Indian Ocean is also very much easy because in north we have landmass, no currents in the north of Indian Ocean. Only we will deal about south or southern Indian Ocean. First we have which current? South equatorial warm current. This is a straight line which is parallel to equator is the equatorial warm current. When it touches a country called Agulhas, Agulhas, it becomes Agulhas current. Or here we have an island nation called as Mozambique. It is called as Agulhas Mozambique warm current. Say with me, Agulhas Mozambique warm current. Okay, Agulhas Mozambique warm current. From Antarctica, we have a cold current coming, which is very much easy to remember because here we have which nation, which continent? Australia. It is traveling west of Australia, hence the name given West Australian cold current. What is the name? West Australian cold current. In Indian Ocean, how many currents we have? At least name them. First one, equatorial warm current. It will transform into Agulhas Mozambique warm current. Later, we have one cold current called West Australian current. Is this clear? Then we have largest ocean, which is Pacific Ocean. In Pacific, we have North Equatorial warm current. North Equatorial warm current, which will travel like this. It is shown here. North Equatorial warm current, while traveling, it will touch a place in Japan called as Kuroshio. Kuroshio. It is called Kuroshio warm current. Okay, while traveling the north, it will touch a place in Japan called Kuroshio, hence the name Kuroshio warm current. Okay, this Kuroshio warm current will move towards this side and it will form. Here we have North America, right? We have North America. That part, here it forms Alaskan warm current. Alaska, we have the place here, Alaskan warm current. It forms Alaskan warm current. Clear? Then, from Arctic region, we have cold currents coming. One is Oyoshio. In Russia, this is the place named as Oyoshio. This is the name of cold current coming from Russia. And another one cold current is California. Near California, this cold current. Near California, we have another cold current called as Californian cold. Okay, repeat now. In Pacific Ocean, what are the warm currents and cold currents we have? First one, it will turn into Kuroshio, Alaskan warm current. Then cold currents, Oyoshio near Russia, and California near North America. California near North America. Okay. In southern hemisphere, it is very much easy to remember. In southern hemisphere, what is the warm current? South equatorial warm current. It will touch the eastern part of Australia and it is forming East Australian warm current. Okay, it is touching the eastern part. It is called as East Australian warm current. Whereas from Antarctic region, we will getting a cold current. This is touching a nation called Peru, hence the name Peruvian cold current. Okay, these are the major warm and cold currents of the world. Just take down definition of currents, factors, and while tomorrow coming, you just make the list of warm and cold currents in each what we call oceans. What are ocean currents? Large scale movement of ocean currents or large scale movements of what? Okay. I thought you were asking, shall I go? Large scale movements of surface water in ocean. Factors affecting ocean currents. First one, planetary winds. What are the planetary winds? Oh, planetary winds. After pressure winds, we have dealt with three planetary winds. Westerlies, easterlies, trade winds. These are planetary winds. First factor is planetary winds or just generally winds. Second one, Coriolis force. Coriolis force here. Coriolis force. Third one, temperature difference or heating by the sun. Temperature difference, heating by the sun. Next, salinity. Salinity is also one of the factors which I have not explained before. Denser ittu andre, highly saline ittu andre, it will sink, whereas less dense it will float. Salinity. Then fourth one, configuration of coastlines and ocean basins. Configuration. If we have a Gulf region, it will turn. Ocean currents will turn. If we have a straight line, it will travel parallel to that. So, configuration of coastlines and ocean basins. These are the major factors affecting formation of ocean currents. Okay. Then tomorrow while coming, you just make list like this. Pacific Ocean. Okay. What are the major currents? Which are cold currents, which are warm currents. Similarly, Atlantic Ocean and Indian Ocean. Effects of ocean currents. This is last topic for the day. What is the significance or effects of ocean current? As I said before the starting of this chapter, they are very much necessary for thermal circulation or circulation of temperature, climate modification. They are very much important because warm currents, when they meet cold currents, they will regulate the temperature of the ocean waters. Next one is fog and storms. Convergence of warm and cold current causes fog sometimes. Fog. Okay. Whenever there is a fog, we see cyclonic activity, and as cyclones will be seen. Next, we have marine life and estuaries, fisheries. Because when warm current meets the cold current, these are high fishing zones. The fishes, we get variety of fishes and umpteen number of fishes at such areas where warm currents and cold currents are meeting. This is one of the statement based question in our previous UPSC questions. Where do we find large marine fishing areas? Where warm and cold currents. And fourth importance is for navigation because these ocean currents are like our permanent winds, okay? Permanent planetary winds. They will flow in certain direction. That direction, if a sailor, if any ships are traveling in that direction, it is easy for them to travel. If they are coming this way, if this is the direction of ocean current, if the ship is traveling in this direction, it is easy for navigation. If they come in the reverse direction, they require some extra amount of fuel. Okay. That is same like our upstream and downstream traveling. These are the major effects or impacts of ocean currents. First one, climate modification. Then we have smogs, fogs and storms or cyclones. Then marine life and fisheries. Major fishing grounds of world or sea. Either you continue. Major fishing zones of worlds or sea where warm and cold currents meet. Where warm and cold currents meet. Last, it is important for navigation. Okay. This completes the oceanography. Tomorrow, don't miss to write the ocean currents, its name according to the oceans. Take one ocean each and you just write few warm currents and few cold currents. We are left with salinity and temperature, which will be covered in your advanced classes. Tomorrow we are moving to Indian geography. Okay, major things in Indian geography, and we can move to what called as environment. Last 2 days of my class will be Monday and Tuesday environment. Okay, thank you.